We try to make our systems similar to how we do our STIs, almost 1 to 2 button operation, where the operator can simply enter a few variables and walk away and not have to worry about the system. When we look at the effluent decontamination systems specifically, those have been tweaked over many years to bring forward the best attributes and features of all those systems. But at the same time, we have to look at every individual facility to make sure that it fits that facility's need specifically. So a containment facility with, say, high solids or low solids, there'll be two completely different systems. So we look at the design of the system up front to make sure that that design meets that facility's need from the get-go, because that drives a lot of the different types of design features that we use for each of the systems. So the biggest aspect we look at when we look at these types of facilities and their needs. So beyond that, the components we use and how the system is designed, laid out from a maintenance and accessibility standpoint is very important as well. If you're not going to be able to get to a component, you're not going to maintenance it. You're not going to work on it. You can't see that something may be going wrong with that component. So accessibility, ease of use is another thing. It's kind of like that saying, if you need the manual, it's too complicated. Retrofits are an interesting topic. Those have to be looked at in a different light. What can be fit into that space to also meet the needs of the facility and their throughput? They may need a space twice the size of what they have to accommodate what they actually need. So sometimes we have to work backwards and say, okay, here's what you can do with what's available. So is that acceptable with this particular technology that we're going to propose? So yeah, you have to look both directions with that particular instance. There's lots of other little things to look at as well. Does the facility have the utilities needed to support this type of operation? Most of the time they don't. So there has to be other facility improvements to support this type of equipment. So one of the things that we do, and this is across the line on everything, all of our components that we use on our systems, non-proprietary. If you want to buy a replacement from us, you can. If you want to have stock from us, you can. You don't have to. You can buy it from the vendor locally. So operationally and that continuity, if you already have accounts set up with specific vendors, you can continue to buy from them. You don't have to buy from us. You can shop prices around, better availability. So that responsiveness of parts for components and things that wear, because it's mechanical equipment wears. So as you do your preventative maintenance, or we do it for you, the availability of those components is higher, and you don't necessarily even have to replace them with the same components. You can replace them with light components as well. So that availability, in addition to what we keep in stock from a ongoing reliability and continuity standpoint, I think is a very strong feature. So in addition to that, we have lots of built-in redundancy within the system. Certain agencies require a specific set level. Others have no requirement for a level of redundancy. Each system has, it's certainly a list of pros and cons on each one, and they tend to have a nested area where they do best. So continuous flow insinuates that essentially the system, once it gets operational, it continues to operate under a condition where it has a very high rate of heat exchange or heat recovery, where the outgoing fluid changes heat with the incoming fluid, and it requires very little heat to maintain that specific condition. This type of a system works very well with low solids applications. It can be retrofitted to work with higher solids, but in general, continuous flow will be medium to low solids applications and is good for high heat recovery. As long as the flow into it meets the flow out and those conditions can be maintained, it can continue to operate. That type of a system does typically come with a buffering tank to help out with peaks and valleys, because no flow from a facility is ever constant, 100% constant. So a batch system is exactly that. Multiple tanks or tanks with a buffering tank will fill up, heat, hold, and cool in consecutive batches versus continuously processing. Now, this system is very well geared for the entire gamut of low solids all the way up to extremely high solids, just because of the way that the batch nature of the process and how the system works and interacts with all the components. There's There's not a lot of fine-tuned tweaking with flow rates and heat transfers. Now, like the continuous flow, batch can have heat recovery, but it's not as great of an efficiency versus the continuous flow. So that's one of its cons, is the energy efficiency is not as great, even with the heat recovery versus the continuous flow systems.